Hello friends, welcome to my channel. In this video I will cover GATE paper 2017 morning shift, thermodynamics and heat transfer I will cover. Question is, saturated steam at 100 degrees Celsius condenses on the outside of a tube. Cold fluid enters the tube at 20 degrees Celsius and exists at 50 degrees Celsius. The value of log mean temperature difference or LMTD is how much in degrees Celsius? You have to give the answer. So, one fluid changing the phase. So, this is hot steam, and from this side cold fluid, here steam only changing the phase. Its inlet temperature THI, temperature of hot fluid 100 degrees Celsius, temperature of hot fluid at exist same 100 degrees Celsius, only phase changes. And inlet of cold fluid, its temperature is 20 degrees Celsius. At exist temperature of cold fluid, it's 50 degrees Celsius. So these two temperature difference, delta Ti at inlet, and these two temperature difference, delta Te at exist. LMTD or delta Tm formula is delta Ti minus delta Te divided by ln delta Ti divided by delta Te. If we calculate delta Ti, it's Thi minus Tci 100 minus 20, 80. Delta T at exist, temperature of hot fluid at exist minus temperature of cold fluid at exist, 100 minus 50, its value is 50. So put both the values, delta Ti it's 80 minus at exist delta T 50 ln 80 by 50. If you calculate this one, you will get 30 by ln 80 by 50 is 0.47. You will get 63.82 degrees Celsius. 1 mark question. Next question. The molar specific heat at constant volume of an ideal gas is equal to 2.5 times the universal gas constant 8.314 joule per mole Kelvin. When the temperature increases by 100 Kelvin, the change in molar specific enthalpy is how much? In unit joule per mole you have to answer. So Ru, universal gas constant, its value given 8.314 joule per mole Kelvin. Then Cv, specific heat at constant volume, its Cv, it's 2.5 times universal gas constant Ru, 2.5 into 8.314, you will get 20.785 joule per mole Kelvin. Then enthalpy we have to calculate. Enthalpy, Cp first we have to calculate. We know Cp minus Cv equal to R. So from here we can calculate Cp. Cp is Cv plus R. Cv is 20.78 plus R is 8.314. you will get 29.099. So molar specific enthalpy H is mCp dt. Mass not given, so take 1 kg, then Cp you got, we already got 29.099 into dt. Temperature increases by, this is 100 Kelvin, this is dt, so 100, you will get 2909.9. unit is joule per mole. 1 mark question. This is 2 mark question. Fill in the blanks. 1 kg of an ideal gas constant R equal to 400 joule per kg Kelvin. Specific heat at constant volume Cv equal to 1000 joule per kg Kelvin at 1 bar. Pressure is 1 bar and temperature 300 Kelvin is contained in a sealed rigid cylinder. Rigid cylinder, this is very important. During an adiabatic process is adiabatic. 100 kilojoule of work done on the system. By a stirrer. The increase in entropy of the system is how much? So data is given. Mass is 1 kg. Gas constant R equal to 400 joule per kg Kelvin. Specific heat at constant volume Cv equal to 1000 joule per kg Kelvin. Pressure, initial pressure P1 equal to 1 bar or 10 to the power 5 Newton per meter square. T1 temperature, initial temperature, it's 300 Kelvin, contained in a sealed rigid cylinder. This is rigid cylinder, so change in volume. Rigid means change in volume. Change in volume is equal to 0 during one adiabatic process. So heat is not going or heat is not coming. So heat interaction with the surrounding is 0. Work done on the system, W steering, it's 100. Work done on the system, so it's minus 100 kilojoule. Increase in entropy del S we have to calculate. So del Q equal to plus PdV plus work done by steering. Here dV is 0 because it's rigid, so PdV work, it's 0. Adiabatic, so del Q is 0. So 0 equal to change in internal energy plus work done in steering. So change in internal energy is mCv dt. If you integrate, you will get mCv T2 minus T1. Work done on the system, so it's minus 100 into 10 to the power 3. It's in kilojoule, so multiply 10 to the power 3, it's equal to 0. So from here you will get mCv T1 given 300 Kelvin, it's equal to 100 into 10 to the power 3. So T2 minus 300, put the value of Cv, 100 into 10 to the power 3 divided by Cv value is 1 into 10 to the power 3. Cancel. T to 400 Kelvin. So here this is stirring work, W in on the system, work done on the system, adiabatic process, or del Q equal to 0. Here inside P1 and T1. Here we got T2 equal to 400 Kelvin. Then entropy equation we will TdS equal to mCv dt plus PdV. PV equal to mRT. So P equal to mRT by V. We will apply this one. ds equal to mCv dt by T plus P value is mRT by V dV. So mCv dt by T plus mRT dV by V ds. Then integrate. If we integrate, we will get S2 minus S1 equal to mCv ln T2 by T1 plus mRT ln V2 by V1. This one also we can derive as, this is not required, but for other examination in ISRO also they are asking. So all three relations you should know. Cp equal to ln V2 by V1 plus, for unit mass, Cv equal to ln P2 by P1, Cp ln T2 by T1 minus R ln P2 by P1. Three relations are there, but here in our question, temperature is available and it's rigid. So V1 by V1 equal to V2. Pressure P2 not given, so you cannot use this one. Here also you cannot use this one, only first one is possible. So we will use this relation. These three relations are very important for other examination. In IAS and ISRO also so many times asked. Problems also they are asking, sometimes only equation they are asking. So these are very important. So here we will use temperature and volume condition. Temperature T2 we already got 400 Kelvin and T1 equal to initial temperature 300 Kelvin. It's a rigid. It is rigid, so V2 equal to V1. So this is 0. S2 minus S1 equal to mCv ln T2 by T1. Put the value, mass 1 kg, Cv 1000 ln T2 400 by 300. If you solve this one, you will get T87 287.68 joule per Kelvin. This is your answer. If you want to do practice this type of question, you can get this type of question in PKNAG exercises. Thank you friends. Thank you for watching my video. Thank you.